Hopefully you'll be able to hear me. What's up, guys? My name is Cherno. Welcome back to another Cherno live stream. Sorry, a little bit rusty today. By rusty, I mean with the setup, because I'm still trying to... I'm just getting back to doing streams regularly, so I still need to find a way to like kind of reconfigure my setup from videos to streams, since I stream with like a dedicated stream PC, and stuff needs to get like reconnected, and I don't... Instead of like buying more cables, I have to replug everything. So I apologize. How's the audio going with the music and everything? Is it fine? So this is what I mean by rusty. Oh, and yeah, and I forgot, because it's been so long. Last time I streamed, like I got another audio interface from somewhere else in my house, brought it like to this room, connected to the computer, and I'm like, oh, what I used to do is get a longer cable for my existing one and then reconnect. So this is what I mean, like just all over the place. Levels are good, great. Stream is 720p. What? Don't think that's correct. No, stream should be like 2560 by 1440. So it's probably you, dare I say. Yeah, it's showing 1440p for me on Twitch. So sorry, the Warrior 1210, you are incorrect. All right, so yeah, I'm pretty keen, and I just washed my hair, so I wasn't like, I don't usually wash my hair before streams, but it was so dirty that I was a bit embarrassed. So that's why it's a bit extra fluffy and weird. But I am keen to stop talking about my hair today and instead actually get some work done on Hazel, because I was thinking about, all right, let me just like catch up. And by the way, I am going to be exporting all of these streams to my Cherno Unplugged channel on YouTube. So just like direct from Twitch. So they should all be there. And they're not yet, because I tried exporting them today, and then I got like an email from Twitch being like, could not export, like it failed, external error occurred. So I'm going to try again later, I guess, but a little bit weird. So anyway, the point being, they will be on YouTube, so you guys can kind of follow along with the story and catch up to streams you miss easier. However, I will still do a little bit of a catch up for people who have no idea what we're doing. Oh, and let me actually, while I'm doing that, let me quickly tweet this out. Yeah, I need to have a little checklist. Okay, 720 on mobile and PC to a Switch limiting it. That's weird. Can I go to like... If I open Twitch in incognito, like what are we dealing with? No, we're also dealing with 720p. What if you need like a... Maybe you need like a premium account. I don't know, that's weird though, right? I don't know, yeah, I also see 720p as the max. But on my stream manager in Twitch, I see... I'm just watching this ad. Oh, gotta update this. I'm not 29 anymore. I'm 30, rip. Gotta update this though. And someone's got 1440p on iPad, no premium. I don't know. Yeah, it looks pretty bad in 720p, doesn't it? This is some streamception. All right. Anyway, so let's catch up. So, go to hazelengine.com, click on the Milanote board, or go to hazelengine.com/roadmap, and you get this. And in this, you can see what we're working on. Render 2025. We're working towards releasing Hazel for free, which is great. Starting with this over here. This is basically the top line here is all stuff that I will be doing, and then this is kind of like the rest of the team more or less is working on this stuff. So yeah, we're just trying to make a new renderer. There's some more information about it over here. Yeah, good, caught up. So specifically though, last time we were basically tossing up how on earth to get, because we want to do this like porting basically the renderer backend from Vulkan to NVRHI. We want to do that, you know, kind of in stages because of my whole like vertical slice driven development philosophy, which I talked about, by the way. Let me see if I can find this. I did a talk at a conference at the end of last year at Yao. Let's, here it is. Okay, so, just mute this. Ads. So I did a talk called The Beauty of Simplicity, Making Your Own Technology. I jumped out. So I did this in 3 cities in Australia. Was it like here? No. I talk about like Hazel and stuff. So you guys can go watch this. It's just on YouTube. But yeah, here it is. I talked about this thing called vertical slice driven development, which basically it has an emphasis on demonstrating, this is like quoted from Wikipedia, across all components of a project. So this is something that I am into, where basically we, you know, you look at the complete pipeline and then you kind of refine things along the way without getting like too deep. Simplicity of survival is just like overall, like with building Hazel and trying to make stuff yourself instead of using like complete solutions. And so this kind of vertical slice driven development concept, which I talked about, like that is kind of, you know, I basically, you know, that's just my technique, we'll say, for software engineering, right? It's just like how I like to work on stuff. And so, you know, if we look at the way that we're trying to do this massive mammoth task of going from one renderer backend to like something else entirely, and how that needs to connect, because I have this mindset of like, okay, I want to get it up and running, and then I want to go back and fill in the blanks and refine stuff, right? VSDD by the diagram seems like vertical slice architecture used in the backend. Well, it is. That diagram is from Wikipedia, I think, just to show what a vertical slice is. And of course, VSDD is, yeah, vertical slice driven development, which I don't think is a thing. I don't know. I kind of made it up, but it's like, maybe there's a different term for it. But anyway, yeah, so ultimately, I decided that a good way to get this whole renderer situation actually working would be by starting in a way, like, I mean, we've gone through and we've done a lot of actual work thus far. And you probably would have seen that over the last like 2 streams, but even I think a few months ago I did a stream on it, and obviously I've done stuff offline as well. Not recently, but in the past on this. We've gone through and we've made a lot of stuff, like, you know, we look at like, I don't know, index buffer, for example, and that's all just like NVRHI stuff now, right? Like we've changed those classes completely, and we've done, I think pipeline is another good example. Like pipeline is just all NVRHI stuff now instead of raw Vulkan code, which is great. So we've done a lot of that stuff already. However, the biggest thing that I kind of want to do is, because Hazel's renderer and everything that Hazel does using Vulkan is so complex and so, like, there's just a lot of it, right? There's a lot of different stuff that gets done. It makes a little bit more sense maybe to strip back that rendering and start with like the core of like a Hazel application, specifically like the editor. And like, because obviously like we're just working on the rendering, so the rest of the application does not need to be rewritten. Like the rest of the engine does not need to be rewritten or ported or anything like that. It's not like we're going from C++ to Rust or something and there's like the whole thing needs to be rewritten. It's just the rendering. And so the editor, I think, is a pretty good candidate for us being able to incrementally work on it, just because the renderer is a really good example of Hazel itself working, because it has the most code. Like it does more stuff technically than just the runtime. But in terms of rendering, it can be the most simplistic, because the UI for the editor for Hazelnut is just IMGUI. It's just dear IMGUI. That's what we use for UI. And then Hazel's renderer, the way it fits in is basically, I mean, not only, but the majority of it is in the viewport, because there's also generating thumbnails, for example, which does use Hazel's renderer. There's also like other views that you can bring up, like the mesh viewer that does also use Hazel's renderer. But the main part, you're looking at is the viewport. And so if we can just not care about the viewport, just have that not render for now, then we can get the rest of Hazel up and running using NVRHI, so that at least we have the application loop working, because that changes as well subtly. I mean, everything changes if you think about it, because we're going from using Hazel's like swap chain and all of that custom Vulkan code to using NVRHI, like to setting that up using NVRHI, but also setting that up using this like device manager, which exists. I think we just set it up for Vulkan initially, but NVIDIA has implementations for this using DirectX 11 and 12 as well. So if we can get this up and running, because this is Vulkan specific now, this is the Vulkan device manager, but it uses the general device manager kind of interface, we'll say. Yeah, it's literally like an interface. It's got some pure virtual functions, as well as like some interface stuff. But anyway, we have this like device manager concept here, and this is from Donut, which is an NVIDIA framework, which uses NVRHI. Since we have that, if we're gonna connect that with like having IMGUI be rendered using NVRHI, which also exists as far as I know. Well, actually, yeah, we found that last time. It exists within Donut. Then we can get that initial, hopefully we can get Hazelnut actually running using this new device manager, so we can make sure that works, using NVRHI for all of its rendering, which we'll use Vulkan in this case behind the scenes. And then we can start being like, okay, let's start being able to go through and render the actual Hazel viewport using Hazel's renderer instead of just the IMGUI renderer, which is what renders the UI. So that's basically, where we're at. I think that that's a reasonable start. And what I was contemplating doing last time was something a little bit different. So I think if we go to like, is it Vulkan IMGUI.cpp? Yeah. What we were doing here is we were being a little bit weird. We were basically going into, we were submitting like, because one of the hardest parts of IMGUI and like UI, I guess, rendering when it comes to, renderer specific or like backend render API specific things is textures, because textures work slightly differently in all the different render APIs. And also it's basically the only resource we actually reference that isn't built into the actual UI framework. So IMGUI obviously will have, the ability to render text and the ability to render shapes and the ability to like render windows. All of that's built into IMGUI, and so it's got its own like vertex buffers to deal with all of that, its own index buffers. If it needs uniform buffers or whatever, it has that as well, because that's straightforward. But as soon as you're like, but I want to render a texture, that's you being like, okay, this is like a resource that I am now giving you. So it's external to IMGUI. And because of that, it does become a little bit difficult to like write a system around that, which is why like for ages, if I recall correctly, back in the day when Vulkan was only kind of new-ish, IMGUI didn't even have a way to render images using Vulkan, and people started writing their own third-party solutions for that. And it all kind of revolves around this concept of an IM texture ID, which is just a void pointer. So it can be anything, right? It's just a memory address pointing to some data. And so you can see that it's basically, it's user data. That's what it is, right? And that's what I mean by it's any data for the renderer backend to identify a texture. And so the idea is that you can make this be whatever you want. And so for Vulkan specifically, we might have that actually be, I think it's just a descriptor set in Vulkan. So we changed it a little bit here, but it used to be, we would basically allocate a descriptor set from Hazel's Vulkan renderer. And then that descriptor set, I think, which that is just a void pointer basically, that is what we would return. And then at render time, that means we can access that descriptor set and bind it like to the pipeline. So that's how it used to work. But then I started pulling, because I didn't want to use NVRHI to do the IMGUI rendering, because I thought that would be more work, even though it's probably what we would want in the end. I started basically pulling stuff apart from, like pulling apart the backend details of NVRHI to get access to the Vulkan code that we need. And then I tried to implement that into IMGUI's Vulkan renderer so that I could keep that as Vulkan. And one of the biggest reasons why I decided to do that at the time, which was last stream, was because IMGUI supports this thing called viewports, which basically just allows you to drag windows out, and they need to create their own windows and are kind of on the fly. And so that's why we have functions like create window, and you can see that spins up like this new, you know, window and swap chain for it and all of that stuff. And I looked at NVRHI and its kind of IMGUI implementation that's part of Donut, and that didn't have anything to do with that. And I think it's not like a huge amount of work, but it's work that I don't really know how to do. So therefore I don't really know what the time investment would be into that. I don't think I have looked at this stuff in the past because I don't know, I had a project a while ago where I made IMGUI run multi-threaded so we could have a render thread and just a draw list kind of, well, just like the main thread and the render thread, and then the render thread would actually go through the draw list and render stuff, whereas the main thread you would use to just like submit stuff for rendering. And then I had like a double buffered queue and all of that stuff, basically how Hazel's render thread works. I made that work with IMGUI a while ago, and so I also made that work with viewports, so with this whole window thing. That was like 3 years ago, I think 2022, if I recall correctly. So I don't really remember what I did 3 years ago though, unfortunately. So I don't know how difficult that would be, but I'm here to tell you that that's basically the way that I think we're gonna go. Audio Nerd, what's up? Favorite stream at 3 a.m. Well, I'll be streaming again in the morning, so that'll be 6 p.m. for you, I think. I'll be streaming about 6 or 7 p.m. your time on Wednesday, so that would be Tuesday evening for you, Wednesday morning for me. So if you have a look at the Twitch schedule, you can see, because I'm doing 2 streams per week and they're at different times. One's in my morning, one's during my evening. This is the evening one. For me, it's 6:15 p.m. So you can catch that stream as well. I'm trying to, you know, stream in different times so that more people can join live. So anyway, so basically the plan then is we're gonna scratch what we were doing so far, which was like with this was it like create image or create texture? No, it wasn't create texture, it was add texture. We were like pulling apart stuff from NVRHI to try and make this texture thing, to try and reduce it back to its original Vulkan stuff so that we can then access that. And I think we have like a bind descriptor sets. When that happens, yeah, that's what we were doing. We were pulling out the texture ID descriptor set, I think, which was an NVRHI Vulkan binding set. And I think that that can decay into like a VK descriptor set or something. Anyway, I don't know. We were doing something weird like that. We're gonna stop doing that, and we're just gonna use NVRHI to do all of the IMGUI rendering. Now, the reason why I think this can work pretty well for the way we're approaching this is because if we just have a look at the Donut framework by NVIDIA, it's because I just realized that, hang on, we don't actually need viewports in IMGUI. Like, yes, we do, like, eventually, obviously we want to ship with them, because not being able to drag windows outside of, like, you know, panels outside of the main window is ridiculous. But we don't need them initially. We can just get this working first without them and then add them in, right? Like, that's not really, it's not like it won't work without them. Hazel will be fine without them. And in fact, most of the time you probably wouldn't even use them. It's just when you do want to use them, you want them to be there, right? So because of that, yeah, we can just basically go with this. So I think there's like this thing called, it's interesting there's external shaders. I guess they might have to be for different things, but there's IMGUI NVRHI, which basically just does, you know, all the IMGUI stuff. So if we basically take this, where's the implementation for this? Though. Oh, here it is. It's in source app. That's included. Okay. So we can basically take this, because you can see what this does. It's actually not that verbose, which I guess I wouldn't expect it to be that verbose because it's not, it should be much more simple. But you can see it's doing exactly like, you know, if we look at render, it's doing exactly what obviously this does, except it uses NVRHI to implement it, right? So if you have a look at like IMGUI render draw data, you can see that goes through, for example, it goes through all the. Now the thing is, it might not even go through all the command lists and stuff because it needs to do that, I think, per viewport. But if we don't have viewports, it might not need to do that. Okay, it still basically does. So you can see draw data command list count, draw data command list count. So we're iterating through all of the draw data's command lists. We're getting the command list out of there, and then we're going through all the, I guess, commands in that command buffer, which is draw commands, which are basically draw calls. And then we're going through, and you can see like if there's a, you know, you can see the code is like there's parallel, right? You've got if use a callback, if use a callback. And then if it's there's no callback or whatever for specifically setting up a render state or whatever, we do this instead, and we end up binding descriptor sets, and it's exactly what happens here. Set graphic state does the bind descriptor sets eventually in the back end, and then draw indexed obviously is this draw call over here. So it's basically a parallel, right, to this. So, and that's really kind of all we need. There's also create fonts texture here, which I believe exists here as well. Yeah, up here. So update font texture would basically do that. So yeah, like it looks like it does everything we need except for viewports. So I think it would be probably pretty safe to just take this. I would like to probably see how this is done. And by the way, I have Donut locally checked out, so I could also refer to that. NVRHI is on the interface for different render approaches. Yeah, so NVRHI, so the RHI stands for rendering hardware interface. And that's basically what that means is it's just an abstraction over specific renderer backends. So render APIs like DirectX and Vulkan. So it's actually quite low level. I mean, yes, it is higher level than just using Vulkan directly, I guess, but I wouldn't call it high level overall, because if you have a look at, let's close this. If you have a look at, you know, for example, creating a pipeline, instead of going through and creating a pipeline using Vulkan, you know, we still have to set every single thing that Vulkan sets, basically. You know, we've even got like, and you want that. If it was high level, then you couldn't really do anything yourself. But like, for example, here's us setting different like vertex buffer layouts for both like the normal vertex buffers, but also the instance buffers and the bone influence buffers and all of that stuff. You know, that is exactly the same as what you would do in Vulkan directly. It's just, it's done using NVRHI so that we can just translate that into DirectX 12 instead of Vulkan if we want. And same with like blend states, and you know, it's basically exactly the same, like especially this pipeline stuff. It does do a bunch of stuff for you, which is good. Like it does automatic like barriers and like synchronization and stuff if you want it to, and like resource tracking kind of. So it does have some features that definitely are higher level and don't come out of the box, but in general, it's a fairly low level abstraction over specifically API backends. So no, it's not like a renderer like PBR or anything. That would be, Hazel does that, you know, and we want to do that ourselves. Okay, cool. So anyway, so if we go back to Donut, and we have a look at NVRHI and obviously the header file as well, then yeah, I guess I can have a look at where this is called from, because that's what I wanted to know. Because see, it does take in a frame buffer. So we do IMGUI render, which does the C++. This is like the building the draw lists that it does, right? So it will go through and it will actually, you know, add draw list to draw data, blah, blah, blah. And then that will like basically push stuff back into the draw list and whatever else. So it goes through and it does that. Thanks for losing where I was. That's what IMGUI render does. And then this is actually what renders it using the backhand. So this does the GPU side rendering. So, and then it does take in a frame buffer. So it looks pretty straightforward. Like, we just need to give it a frame buffer, and then I think it's just up and away. You know? So that means that, so that means that if we go to, I think there's like Vulkan IMGUI layer. I don't know why this needs to be, why is this Vulkan specific? I guess because it needs to set up like, what? It needs a you need to create a descriptor for, because we're doing it for Vulkan. I guess it needs to be initialized and stuff, and it needs to get, I guess, all of this stuff. So how does this work? How does the initialization work? So if we go back, and you can see it takes the device and then this shader factory. Because yeah, I was also gonna find out about how the shaders work. So yeah, it just gives it the device. I guess it does everything. It gets everything it needs from the device, and it creates a command list for it, creates everything. Yeah, okay, that's pretty good. How does it allocate descriptors and stuff though? Does it create like its own pool basically? And you also might not be able to submit custom images into this, so we might have to expand it on that. Because this is probably just used for debug, but obviously since we use it as main UI, we need more stuff. But it's okay, it's still a good start. So what was that? So device, and then yeah, shader factory. So why does it need this shader factory? Because this is a donut shader factory. I mean, I'm guessing it has, where are the shaders anyway? They're kind of here. Don't know what static shaders has these shaders here, but that's only if it gets included into this. Otherwise, let's have a look at what it does with that shader factory. Create auto shader. And then that will do what? Create static platform shader. Yeah. So that's something we're gonna have to, I mean, this doesn't matter too much just because we can obviously just use Vulkan for now. And then we don't really have to worry about it too much. But yeah. So I would say we probably don't need that. And obviously you can see this is tied directly into with donut as well. Okay, cool. Well, I think I'm pretty satisfied. I'm just gonna copy and paste these two files probably. The question is, where do we put them? So at the moment, this is all stuff, all like in platform Vulkan. I wonder if we probably should maybe, maybe not though. Maybe this would just go into Hazel IMGUI. I think so. So we'll call this IMGUI renderer. Probably. Okay, can keep that. Yeah, shader factory we want to get rid of. It's kind of static for us anyway, like it's global. So I'm gonna change this to be, I don't know why this is public. It's a bit weird. Oh, so is this stuff set? Is that why? Because this stuff actually is set externally? I thought init would do it. But maybe not. Maybe that's why. Okay, well, let's keep it public for now, but we will kind of change that probably. And yeah, we're gonna end up changing this, I think, quite a bit, unfortunately. I need that precompiled header. That's a bit weird. Why that would be included here? Probably don't need half of this stuff. There's no static shaders for us. None of this. Let's just replace that real quick. Doesn't it include that in the header file? Yeah, they've got a lot of duplicates here. Strangely. Okay, what is the issue with this? Oh, I'm missing the namespace. Yeah, so the shaders, see, here's the thing, right? So I haven't really given the shader what would be the new shader system too much thought yet. However, we do need, yeah, there's some information about it on, if you go to hazelengine.com and you go to the Millinode board, then there is some information about it on, you know, here, in the Render 2025 page, because we have to like, think about this either cross compilation or maybe even dropping GLSL for HLSL. And so therefore, yeah, we definitely need a way to handle that. So the way that they've set it up is not ideal, because I think they've just got different shaders maybe. So you can see so they have Donut and then IMGUI Vertex, which is already compiled as far as I'm aware. And that is gonna be, so where is that? I mean, I don't know if it's there. So the source is in HLSL, which is fine. I guess that's not bad actually. And then I think what they do is, it's probably in build, isn't it? Shaders, compiled shaders, yeah. So they've got 3 different directories. So they've got DXBC, DXIL, and then SPIRV, right? So DXBC, DirectX bytecode, that's for DirectX 11. DXIL is DirectX 12, and then SPIRV is for Vulkan. And so these are the compiled shader binaries for those 3 different APIs, right? And all of them are here. So, and then basically this create auto shader will basically read in one of those compiled files based on what the current platform or the current backend is at runtime. No, I haven't really looked into SLang properly yet. But anyway, so we, and then I don't know what Donut Make Platform Shader does. Probably, yeah, it probably just concatenates some strings and figures out what the, oh, okay, right. So it actually does do static shader. Yeah, but that's just this. It's just, yeah, it mostly just, you just give it like, I guess a name or whatever. And, oh, static shader, probably for the ones that it included here. So these were probably already, yeah, so I'm sure that donut with static shaders just means that the actual shader bytecode is embedded into the binary, basically, by including it into this file, and then you just read it as like an array of bytes. And then if you don't, if it's not static shader, then it actually reads it from a file on disk. I would probably make it static. Like I'd probably, yeah, just use static shaders. So what we can do is, man, to make that work with, oh, but we don't really have to make that work with Hazel's pipeline, do we? Oof, I don't know. Because what we could do is we could actually grab the, so you can see compiled shaders, and then it'll go into like, well, actually this doesn't say which one to go into. Because see, there's IMGUI vertex.bin, but here it's like, it seems to be .spurv instead of in the spurv directory. So this seems like it's a bit confused. So I was gonna say, we could just take it from here, the already compiled version. Because if we were to build it ourselves, like we obviously can using Hazel's shader compiler. But I guess we probably should long term. Okay, yeah, especially because like obviously Hazel has a way, like didn't we start porting the Vulkan shader stuff? Like, does this have anything to do with NVRHI? I think it does. Yeah, I think it actually does. But Vulkan shader compiler, right? Because this is important. We obviously want to retain this functionality. I'm just wondering if that does anything with NVRHI. Yeah, it does. So I did kind of port this, I think, to NVRHI. So does that mean we can full on get a shader? Surely not, right? Because here are all of our shaders, which go into our shader library. Which will get compiled if you are not in the runtime. So does that mean that this works? I don't know if we probably have never tested this code path though, on the other hand. But I guess we can try. So this gives us our shader handles, basically. What does this want though? How does this work exactly? What is this? It's a shader handle. Yeah, so we have both of them here. Well, I mean, that would theoretically work, I guess. So if we just grab the actual raw shader code. So if we go to like, yeah, donut, and then shaders, IMGUI, vertex, and pixel, we need to change it into like kind of Hazel's shading language-ish. It's not really a shading language. It's still either GLSL or HLSL, but it's just split up a bit more. Where even would that be? Hazelnut, I think resources, shaders. So if we, I mean, we can paste this in, but we're gonna have to, there's like binding helpers. That's not too bad actually. So if we have a look at another HLSL shader, like this one, then, oh, there's a compute shader. Because these basically kind of get I think, collapse into one. And then we sort them out. I don't know if this would be fragment or pixel. I think either work. And then binding helpers. What's in binding helpers? That doesn't even look like it's here. No, it didn't include, it's here. Ah, because we want this stuff to work. Yeah, it just lets us do this stuff like this. Because this is going to differ if your target is Vulkan versus DirectX. I guess we won't take that file, but we will make stuff like this. Because it's only really used here. It's just declare push constants. So this is just going to be a VK push constant. Probably need to track down the syntax for this. Declare C buffer. Yeah, because it's like constant buffer. I think it's this anyway. And then it's this. It's a bit weird. Register C buffer. Ah, because it's this register. Right. So 0, 0. Reg space. Oh yeah, so C buffer is a buffer, so it's B. But what's space? Oh, it literally says space. What the heck is space? I don't know, I've seen space before. Like literally the word space is in there? That's what it looks like. But anyway, it seems to be B0 and then space 0. But that seems a bit weird. What is like this space thing? Oh, space is actually indicated here. I already got rid of it. Yeah, because space does not seem right. Let's have another look. Oh. No, that's the numeric space. Right? Register C buffer. Which takes in the thing in space, so B, reg space. Then goes into here, and it looks like it has the word space in it. So I guess it does have the word space in it. Okay, that's weird. Oh well. I guess that's maybe like, I don't know, would it be like set or something? It's weird. But either way, that seems fine. Have you dropped support for GLSL? No, not yet. Maybe will, but not yet. Okay, so that seems to be done. So now we have, wait, I did it here? Or is that correct? Oh yeah, because I just got rid of this. IMGUI.HLSL. Vertex and pixel, and they're both in one, and then we've kind of gotten rid of everything else. Wait, but where's, oh, there's constants. Okay. That seems reasonable. As long as we obviously bind everything. Yeah, so what I want to test out, I guess, well, we'll just take this and then we've just got IMGUI.HLSL, and we'll have that be like the first shader. So that means that if we have in fact worked, which is doubtful, it means that in IMGUI renderer, we don't need this vertex shader, pixel shader. I mean, we still do, I guess, but we still need them as separate shaders. But to get them, we would just do renderer get shader library, and then like, I think get. Let's just include that first. Yeah, I think it's in shader. Oh, we need renderer though. And then we would just type in IMGUI, I think. And that gives us a shader. But a shader, this is like a full-on, this is a shader program, not just a single like shader stage. So if this is our IMGUI shader, then from there, I think you can do get handle, but that doesn't make sense because mhandle. That doesn't make sense because it's got handle per stage. So that's why if we go into Vulkan shader, which should be combined with just shader because there is no Vulkan shader anymore, then you can see that I think we have shader handles. We actually have a map of shader handles per shader type. Can we get those somehow? Yeah. So I think let's make this a virtual function like this for now, probably. Like eventually it won't be because it'll be in, everything will be in here. But just to get rid of this for now, we'll get rid of that. And we'll put this in. And that will just let us easily basically use the same API that will be our final API. And what was that called? That was called, where was the shader? That was called get handles. Let's do, get handles because it's a map. Okay, sure. For now, we'll do it this way, but okay, no, let me just make something a bit more final, I think. So we'll just have it return NVRHI shader handle, get handle, and we'll put in the shader type. And then there should probably be a way to not, I think I'd want probably something like this. Because sometimes you just have like a compute shader, and so you don't necessarily have to type in compute, but sometimes you have something where you want the individual, like, but on the other hand, why do you want the individual? Shouldn't we just have the program and that's it? Like, what is this used for? It actually looks like it's used individually, but how does it get? Oh, because it wants individual things. Interesting. Okay, sure. Maybe I think I'm just wrong. I think I'm just not remembering what Vulkan actually wants at the end of the day. What's up, ABZ, B2806? What's up? Thanks for the kind words. Yeah, I think I'm probably just misremembering, not remembering what it's supposed to be. So then let's go back to here and we will add in those functions. Well, this will just probably return shader handles dot begin. Just gives you the first one, I guess. Really? What's maybe I haven't written C++ in a while. We'll get back to that error. Does this like not have a copy constructor or something? It's ref counter pointer, of course it does. Maybe something to do with const? I marked the other one as const. Well, it is const because it's copying it. Oops, let's implement in here. Or maybe I wanted to see begin. Probably not though. I don't think it should matter. Oh, I'm an idiot. Because it's a map, not a vector, so lol. My bad. So it was returning like a tuple basically, and it needs to know which one. Oh whoa. Just slap that in to a random function. Nice. I wanted to put it here. So it gives you the first shader handle inside this map. Okay, so back to IMGUI renderer. So yeah, so this is basically what we can do. We can do get handle, and then this will be NVRHI shader type vertex, and then we do the same thing for here, but it's the pixel shader. And now we got them. I guess you can log them if they don't exist, but probably not, because they should by here, otherwise they would have errored earlier in the engine probably. And then everything else looks pretty good. Yeah, reallocate buffer we obviously just renamed. Update geometry, same situation. Cut pipeline state object and get binding set. So that's it. That compiles. Good. So yeah, whether or not it works is obviously a different story, but it's, yeah. How did you handle font scaling in IMGUI? Do you just reload the fonts at the new size when the window resolution changes? Well, we don't like dynamically scale fonts. Like as in if the window size changes, we don't need to reload the fonts. They're still the same size. The window size changes, it just more fits onto your screen. But you can change the font size like at startup basically, and then it will, yes, load whatever size you want. It'd be good if they had, I contemplated rewriting like I guess adding support for like, you know, SDF and MSDF into IMGUI, because that's what we use in Hazel for like, you know, the actual Hazel rendering for UI, like for game UI and for other text you might have in your 3D world. But, it's not that big of a deal. Won't that mean the font size might be very small on huge resolutions? Example. Oh, you mean for like, no. So that works differently because that's DPI scaling is different to resizing a window. If you've got your actual like display settings, if you've got like the scale, you know, set to not 100, then I think there's something in IMGUI or it might not be in this branch because it's a bit old, but there's something in IMGUI or in GLFW even that like it uses your monitor scaling to make everything the appropriate size. But that still happens at startup. That doesn't dynamically happen. Like, I mean, it might actually. I think there's some kind of like, I think GLFW has something like, I don't know if it's here, but set process DPI aware, and then there's like some DPI, like maybe DPI change callback or something. I don't know, to be honest. I haven't tested that. I'm always at 100% scaling because I have quad HD, like, you know, 1440p monitors, and don't really like using 4K monitors where you have to use scaling. Okay, anyway, let's continue on with the work. So, since this kind of works now, I mean, we still go through like Vulkan IMGUI, for example, to submit images and stuff. And this, like, I'm tempted to just fudge for now, like as in make it return nothing or something. But like the thing is, it's not that hard probably. Because what do we realistically have to do? I mean, we were kind of doing it before inside. Where was it? It was inside this import Vulkan with textures. It's just add texture, I think, had to actually allocate like a descriptor set for us. But why? Oh, yeah. Because it has to be in IMGUI's layout and stuff. Yeah, that makes sense. But how does it, I mean, it has to do it, what we just wrote, like as in what we just took, I should say, from NVIDIA, also has to do that because it has to do it for the font thing. So here it is. I guess it just sets it somewhat statically, creates a binding layout. Oh no, but how does it set it? Because that's fine, that's just the pipeline. But then obviously when it renders, it does set graphic state, draw state, and then we have this, get binding set. And so it is command texture ID. Okay, but how does it allocate one for the update font texture? Does device create texture? Fonts texture. Oh, it just says fonts text ID. Oh, begin tracking texture state though. Set permanent texture state, shader resource. Wonder if we'll have to do something with that. Because what does that actually do? I think it's just I don't think it does anything with Vulkan. Oh, but also, oh no, I missed this part. Get binding. This is what does it. So it does this at draw time. That's interesting. Huh. Oh, and it caches it. I mean, that's a pretty genius way to do it, to be honest. Like, I have no idea how this works practically, but in theory, that's pretty good. It sounds pretty good. It's just like lazily doing it, you know? So that would mean technically that if you say submitted an image and you want it to render, then at the moment we have this get texture ID, but really what this would be is just like return image, like get handle. And I think that's it. Like what is this? This is a texture handle. And I think that's it. Because basically what used to happen is the like it already wanted a descriptor set, kind of, right? And so we had to kind of go through this function, but because the renderer actually sorts out its own descriptor set at render time, you could just give it the source basically, which is just that. So that's kind of interesting. I mean, for a specific image layer though, how would that work? Because you'd need to get this sub-resource view thing. And see, that's a Vulkan specific thing. So I have no idea how this would work, but obviously like for now, it's okay. Because that doesn't come up that often. It's not gonna be like, it'll break some things, but not much. So we could just make it return the same thing for now. Same with the MIP situation. Obviously not the correct solution, but for now, you know, let's just get it working. And then everything else should just work, I think. Okay, cool. So I'm actually pretty confident that we can probably maybe get something running. Let's just build all. There's going to be probably a bunch of errors, but we'll go through them. Okay. Don't think that needs to exist anymore. Wasn't even used. Nice. Descriptor set manager. This is a complete disaster, this file. I mean, this still kind of exists. Like, maybe I could just make this work. I mean, Vulkan texture 2D is gone. We'll just make this file work, but do nothing. Because we're not going to be going through this code path just yet. Because this is for Hazel's renderer, not for IMGUI, and we're just getting IMGUI running first. Okay, Vulkan image, Vulkan texture, and Vulkan render path. Vulkan render path. This probably gets deleted. Yeah, I mean, this doesn't even use Vulkan anymore. Because that's a different thing entirely. Vulkan image, Vulkan texture inside Vulkan compute path, sure. And then we got Vulkan compute pipeline. Didn't we already rewrite this into just compute pipeline? Oh, this is pipeline, not pass. So what's pipeline compute? That's fine. So why are all of these errors? Does not override. Really? Oh, I made them non-virtual and stuff. I guess we started rewriting this. Oh, we kind of did rewrite it. Okay, I see. Yeah. I guess we'll just... This is still work in progress. We decided not to... I think this is kind of where we decided to stop, actually. Where we were like, you know what? Let's not do this yet. Let's get IMGUI working, I think. Oh, this is excluded even from build. But I'll still do that to it. Yeah, Vulkan renderer also doesn't really, this is basically gonna get, it's not gonna get deleted, it's just gonna get completely rewritten because this is Vulkan specific, whereas it's gonna be not Vulkan specific anymore. So I think we also just get rid of this for now. But doing that's gonna probably cause a lot of problems. I should probably just get rid of each function individually or something, because otherwise I don't think it's gonna work. What's with this queue situation? Okay, let's just go with this first. Asset manager base. What's the issue? Syntax error namespace. Oof. That's not good. Okay, that must be, I think I did something wrong. Yeah, I think, okay, so with Vulkan Renderer, so Vulkan Renderer, I don't think many things call that directly. I think it actually flows through, it should be flowing through here, as far as I'm aware, through Renderer. So since it's flowing through Renderer, oh, we actually excluded Vulkan Renderer from everything as well. Yeah, I messed up the brace. That's why it got annoyed. If we just don't even worry about this, I think we should be okay. So let's do that. Now let's focus on getting this file compiling. So this is just, this can just be that. Yeah, so this we're going to return null. Because that's going to get completely changed, I think. Yeah, this whole Vulkan render data thing. We just changed that to render data. And then yeah, the descriptor pools and whatever else, like that doesn't, we'll keep that, I guess, but we're not gonna actually do anything with that. Okay, why is this upset? What? There might be multiple of these. Yeah, there are. This is for IMGUI, isn't it? Yeah, like I just don't really want to delete too much stuff. Obviously I can look at the diff and git, but I don't want to delete too much stuff because I want to just make sure I don't miss anything, you know? And this stuff doesn't really need to exist anymore, actually. That's fine to delete. Yeah, but like begin render pass, like this is not, this needs to be redone into, why is this even in renderer? This is Vulkan specific. That's very weird. Why are these errors though? Because this should be, isn't this in render API? Oh, we nuked it all from there. Damn. Okay. Well then, yeah, we gotta comment out like every line here. But this will be filled in with what the contents, well, this will actually have the implementation now. It won't be like a, an indirection. Now, create an environment map. Ugh, okay. Oh, this actually kind of already is rewritten. I think I decided to somewhat arbitrarily rewrite this. Guess I got up to this. Oh, but this does some Vulkan stuff at the end, I guess, maybe. That's not hard to do. Oh, it's an array. That's a little strange. I think we should be able to convert that, but whatever. Cool. Hey Cherno, after all the experience you have, how is your ideal high-level API for doing multipass rendering in the most flexible way? Well, Hazel basically has it. It's kind of hard to explain. But yeah, I don't know. I might make a video about it specifically, but you know, the way that scene renderer is laid out is my preferred way to do things. So scene renderer just takes in like a scene, which is the data, and it basically outputs an image. You know, it gives you an image that you can then use for whatever you want. And then that uses a lower level stateless API to actually do all the command buffer like work of like what you actually like what a pass actually constitutes. But then you can also define things into things called render passes ultimately, which is like a high level layout. I mean, it's fairly low level, but it's a layout. It's like the specification for what a pass should be. And I don't know, I like doing it somewhat. It could easily be taken in as data. Like if you wanted to specify this in like JSON or I don't know, YAML or some other language, like this an external resource, you could, but I just like working in C++ for it. And then you just define like your input and outputs for your render pass, as well as obviously what it does, so like the shader and other pipeline features. And then you just, begin and end that pass, and within the context of that pass, you can render geometry. So it's, I don't know, it's pretty like, I don't think it's anything too like, you know, tricky. It's pretty straightforward. I like to try and keep things simple. But it's also like, there's a lot of room for innovation, or like not innovation, but like it sets you up pretty well, I think, for if you did want something a bit more flexible and custom and data driven, then you definitely could do that pretty easily with the way that it's actually put together. So that I think is good. All right, so yeah, let's do a compile of everything again. Okay, we're actually up to linking errors, so that's really good. So this is a good opportunity for us to take a quick break. So I'll be right back. I'm just gonna like get some more water and stuff. And then we'll continue. Okay, I am back. Yeah, so we got some linking errors, which is good. As in good that we've progressed from compile errors to linking errors. I just put on a sweater because it's getting cold. Oh. Yeah, so what do we got here? Pipeline specification. Hazel pipeline get specification. Okay. That just returns a specification. I might just do a little screenshot of all the errors, or at least fix all of them at once. Because otherwise, it's going to take a while. Pipeline get shader. Here, let me just do a little screenshot of this, just so I can see it here. Okay, so we got yeah, get shader here, which because I guess because it's still in Vulkan pipeline, isn't it? Oh wait, is it? No, we moved it all here. Oh, okay, cool. So yeah, so the shader then should just be in the spec, So return m specification dot shader, I think. Okay, that's done. Then we got image view create. Okay, image view. Oops. Image view create doesn't exist, apparently. Didn't we kind of made this? Oh yeah, because it kind of doesn't. Yeah, it just does this, I think. Return ref, image view, create, and specification. That's it. Then we got Vulkan material. What did I do with Vulkan material? Did I just remove it? Yeah, I did. So what's trying to reference that? Oh, maybe material .cpp. Yeah. Create DXGI factory inside IMGUI import DX12. Didn't realize we were compiling that. We'll come back to that one. Descriptor set manager. Oh, invalidate and update. Yeah, it's because we accidentally did two functions at once. I'm going import DirectX 12. Where are we doing that? I thought we weren't doing that. Does it look like we are? Okay, oh, this is still an abstract class. What? How is this an abstract class? Because it needs this stupid function, which I probably need to. It just needs an identifier, which I think is, well, we can give it this, I guess. That's ultimately what it is. Could even give it this. Hazel, a hobby project, or I guess more than that. It's a bit more of a serious project. Love your vids. Nice catching a stream. Thanks, cute cat. Fear of Darkness, hello. Yeah, so this thing, IMGUI build, which is like the IMGUI Unity build. Because it includes this. Okay, I guess we can just not do that for now. Was that the right IMGUI build? Yeah. Oh, I unloaded the projects I didn't want, I think, so we should be okay. Still building. Oh, look at that. We have succeeded. Okay, let's run this. This is gonna crash immediately. Oh, look, we got a window. Invalid shader type specified. Okay. Why didn't it tell me where? Yeah, now it just exits. Is it actually, like, what is it running? I just actually don't know. Like, I don't know what I made it do. So, I guess it's in like window.cpp. Because it doesn't do any of this. I mean, it's still kind of... How does the main loop work in Hazel? Dare I ask? Like, do we get into application on init? Like, we don't get to here, do we? Let's put a breakpoint here. Does render init run? No. Oh, well, it still comes up with this verify failed thing. But it doesn't make sense, because if verify failed, like, it's supposed to break the debugger there. What? This is bizarre. Yeah, I guess message box is on. If not dist and Windows. But where's the... And it doesn't even do the message box anymore. It did it like the first time. Oh, great. That's weird. We might have to do a clean build. This might just be a bit messed up. Because it's not really working like it seemingly should be. Okay, well anyway, invalid shader type specified is obviously some text that we've written, so let's search for that. Ah, it is frag. Okay, so it is compiling. I don't know why the debugging is not working, but it is compiling. It's just this is supposed to say frag, not pixel. Probably should be able to accept either, but let's see what happens here. Oh, that still failed. That's almost impossible. Because it means that... But it's also very annoying because I can't actually debug it. Like, the breakpoints aren't working, so... Yeah, I guess we'll do a clean build. Might even restart Visual Studio. Sometimes it's just too much for it to handle, you know. It happens. Yo, Cherno, why did you choose C# as the gameplay language? I just loc C++ and would like to do gameplay in it. Is that possible? Well, C# I think is basically objectively the better language for gameplay because it's Like, why would you not use C#? What's wrong with C#? Why would you not use C#? C++ is just a little bit too, like, lower level, manual. Like, there's less, because it doesn't run in like a VM. It's a bit less. It's like, it's less portable. It's like it's hard. Like, it's much harder for us to present behavior for a game in C++, which is like a compiled platform specific language, than it is for C#, because C#, apart from the language being higher level and having an excellent library, it also allows us to treat that part of the game as like an asset, as like, you know, the behavior of the game and all the scripting for the game is an asset, as part of data. Whereas C++ makes it a little bit more like, you know, core to the program, which kind of, you know, apart from writing the language being harder and harder to iterate on and longer to compile and all of the issues that come with that, it's also harder from a pipeline kind of workflow point of view. So yeah, I like, why, apart from you potentially maybe having more experience in C++, or like if the C# scare you or something, like I just don't know why one would prefer C++. Well, like, obviously you could technically make C++ work, but you just wouldn't. Like, you would just, it's just not ideal, you know? Okay. Why does debugging not work? This is really becoming annoying. My settings must be like messed up or something. Debugger type is set to mixed. That might be why. Let's do native only. Might have to do it for this as well. Yeah, there we go. Okay, so render init, and then I'm guessing when we do shader load, this is where it happens, right? Is this the verify that fails? Yeah. Oh, vertex, because I wrote bloody vertex instead of vert. That's so annoying. Vert. Okay. No message. Nice. Well, now we're getting this, which is good. Compile succeeded false. And I'm guessing this is the IMGUI shader. So that didn't compile because missing entry point definition. Yeah, it probably just wants it to be called main or something. Oh, it is called main. What? What does it actually want it to be called? What do you mean missing entry point definition? How did it try and compile this? I'm pretty sure the default entry point is main, so that should have worked. Okay, well, let's try again. Oh. Now we get an issue here. Okay, well this is not, this shouldn't exist. So we'll just ignore that. I guess because I like moved the mouse or something. What? Can you get off my back about this mouse thing? What's the problem here? This doesn't exist yet. Wait, mdata? Wait, what do you mean this doesn't exist yet? This is a bit bizarre. We're in here, but then we somehow get to here. Print assert message. I guess because we're inside the message box. Ah, that's why it was crashing before. But does that mean that get window context might... I don't think that exists. Yeah, this is all garbage. Get user pointer, because it's probably not that. Like, it made it without it, I guess. But how do we even get here? Okay, that needs to be sorted out. That needs to be sorted out, but I'm gonna just ignore it for now, which is not the best idea, but that's what's happening. And I'm gonna just do what's this? Yeah, we'll just set this to 0. Or we could just do and false. I don't want we don't need the message boxes because we've got a debugger attached. Oh, I should update the info because we're not really quite working on multiplayer. Working on the renderer. C# performance is pretty good. But also, like, C# is very fast, which is great. You can just Google it. But you can use, the thing with Hazel is you can easily use C# with C++. So if in your little scenario of like complicated infinite world gen like Minecraft, you could just you could do that in C++ if you like really want good memory control and whatever else like you might want. You just need lower level control of something. Do it in C++ and then just expose that function to C# so you can like call it however you like, you know, and like communicate marshal the data between C++ and C# however you like. Like you can do that with Hazel, which is good. Okay, so anyway, let's come up here and let's debug this compilation because I'm just interested in why it's complaining about the entry point. So compile log get Vulkan binary. Like what is it say is the entry point or whatever? So just return false. Oh, because compile failed. Let's go into compile. HLSL. Main. Here's the entry point that we hardcode basically. So why does that not work? Oh, okay, this says it's okay. So this is the vertex shader probably. Or maybe not. Maybe the vertex shader doesn't work. Oh. Huh, weird. Missing entry point definition, but it's main. What? It's literally called a main. Wait. This is wrong. Lol. These are flipped. This is the... This is the pixel shader, and that's the vertex shader. I think I must have somehow lolled them. Okay, let's try that. Okay, that still failed. For the same reason. Okay, that's odd. Oh, well actually no, I might be wrong. Lol. Pixel shader input. Oh yeah, this is the out color. Yeah, sorry, I'm wrong. So yeah, so this is in fact, it just returns this as an output. That's what I got confused by. And then VS input is that. I don't understand why it's saying that it's not. It can't find the entry point. There's a function called main. It's so strange. This might... And this is different because it's a compute shader. Like it's specified right here as main. Let's make sure it's going through this code path. But it says it's okay though. And failed is false. But then here it says there's an error. Isn't that weird? It returns okay, but it's got an error. Is that normal? That's so weird. And the problem is that's so strange. I mean, I could just obviously ignore it, but I don't know. Like, surely this wouldn't be crazy, you know? Oh, you know what else we should do though? We should actually have a look at what it's compiling. So, shader source, right? Let's have a look at shader source. Stage. Wait, what? Is this right? Ah, look. What? Okay, I think somehow the source code is read in as wrong. Look at all this. Like, what is that junk? I think it's pre-processed it wrong or something. Okay. I don't know how that happened, but I'm guessing we land in here. Yeah, this looks right. Okay, so then what on earth does it do with this? Oh, wait, so it's already split it up here. Yeah, it has. Okay. Okay, so it's raised the comments apparently, but created a lot of new lines. We can probably call that. So we're looking for a hash. And it does say pragma stage. Vertex, stage positions. Start of stage 0. That seems wrong. Then it does the same thing. This will be the fragment shader. Still start of stage 0. What? How? What? This doesn't make sense. It always starts from 0. Did this get changed or something? I mean, kind of, but not really. Yeah, I mean, this shouldn't have made a difference. Start of shader. Look, well, start of shader stage is written here. Oh, this is different though. This is preprocess header, whereas this is preprocess shader. Where's that function? This just doesn't make any sense, because like, how does it work? Okay, let's put a breakpoint in here and let's just change. This is baffling. It's kind of, to be completely honest, this is baffling. Let's try do like, you know, the PBR shader first, just so we can see what on earth it does and if it even lands in the same code path. Okay, it looks like it does. So it's got this, sure. Skips the version. I mean, the only difference is it skips the version for GLSL. So the position's slightly different, but otherwise it was fine anyway. Then we go through and we find that, we find the vertex shader, but start of stage is in fact 0. And then we find the next one. Okay, it's a version or whatever. We'll find the next one. Okay, what is this? Oh, these are includes. Whatever. Eventually, we're gonna land back in here. Oh, start of stage is now different. It's 2,270. So what modifies start? Oh, this. Oh man. So there's an if const expr for GLSL only that does this. So that's probably why. Okay. But that's so strange. Like, wouldn't you? And then why would you have vertex at 0? Because that includes the. Vertex at 0 includes, because I guess because you want to include the version, but what? So you pragma stage vert, you just trim that or something? Does that include it? It does include it. I guess it's fine with it or something, I don't know. But I'm just wondering why on earth you do that. Ah, it's probably because the version comes... For some reason, the version comes before the pragma stage. I think that's why it has to happen that way for GLSL. I don't even know why that is though. You should probably mandate it to be the other way around. Zang Thirth. Thank you for the Prime sub, appreciate it. I don't know if I can just be like, if it's HLSL, then let's just do this, basically, before we do that. Like, what does that do? Doesn't even go there. How? Oh, it probably does. I just didn't wait for it. Well, let's go back to making this happen first. So start of stage it did 25, and then the second time around it did 708. So if we have a look at the shader sources, I guess this is looking better. I mean, it still has the pragma stage vert, but it doesn't have that. And then, yeah, the frag works as well. So that looks pretty good. It does have pragma stage. I don't know if that will compile. Oh, it did. Cool. Well, there you go. Solved. Your engine uses Vulkan, right? How's it like working with Bevy? Yeah, it uses Vulkan at the moment. Well, it's basically going to use Vulkan in DirectX 11 or 12 at the moment. So we're kind of moving away from just Vulkan. Excuse me. So yeah, it's not like SpareV's fine. I don't really have any complaints. SpareV's pretty good, it seems. Anyway, we don't really need this, right? It's gonna, we're gonna do, now that we're kind of running, we're gonna do so many things here that we don't need to do because we're just focusing on IMGUI for now. So it's gonna be interesting to see everything that happens. I think it's probably compiling all the shaders or something. Okay, so here render init tries to get the current device, and then that kind of fails because I guess it doesn't come from here anymore. And neither does the physical device. We have an NVRHI device handle that we mostly use. And it's trying to do that just so that it can get like these properties. So VK physical device properties. It's gonna be fun translating all this stuff, isn't it? I mean, that equivalent stuff is probably in here. Although it might be specifically in the Vulkan one and we might have to expose it. What was it called? VK physical device properties. No, it's not here at all. Here it is, yeah. So here it is, device get properties. What's this function? Pick physical device. So we just want the vendor ID, the device name, and the driver version. Well, yeah. Okay. I guess we could try and get that stuff. So I think it would be like application. Do we have a get device manager or something? I don't know how we should make this work. Ah, here it is. Okay. So this gets us the device manager, which as of now, we can technically cast it to, but none of this is exposed though. So we can't really, it's all internal to this file. Unless we build an interface for it, which we can. I just don't know how. I guess we're just gonna leave this as a big fat to-do. Because otherwise, yeah, I don't really care about that now, but I will eventually. Slang I haven't looked too much into, but like, since HLSL can be compiled into other shader languages anyway, it's kind of not, I don't really see the benefit but I haven't looked into it. So if someone can give me a really good reason why I should care about that, then yeah, let me know. Oh, I'm getting real tired. I'm glad we got this up and running. Yeah, we'll just like dump GPU. So sRender API is null because we don't make it, and that's the thing that's got this. Ah, because it's stored in Vulkan renderer. Well, I don't know if we should have a per renderer one of these. What code theme is this? It's my own theme based on GraphBox. Don't really know what to do here. We'll just cheat for now. Oh, it's this stuff again. Oh, maybe not. Oh, okay. So this calls an animate render present, which that shouldn't really do anything, does it? Like, what does that do? I don't think we need to do this. The heck does run garbage collection do? Ah, the resource destruction stuff probably. Oh, because this goes through passes again, which we don't really care. I mean, we might care about callbacks for this stuff in the future, like events, but just not right now. Okay, so that's actually fine. That's not a problem. Does this not exist? Yeah, clearly. Because it gets some weird. I guess because like it tries to get this user point, but it's not. Somehow it's not that. Or maybe. Do I ever set this? Yes. Shouldn't you do this like, I guess you have to have the window first. I should probably do this up here though. Maybe that's the issue. Otherwise it's creating another, no, it doesn't make sense for it to create another window, I don't think. And not flow through this code. Okay, yeah, that worked. Okay, so now we're on renderer 2D in it, which again, we don't need to do yet. Let's try and create a render command buffer. I guess we just disable all of this. We're gonna end up disabling like all of the rendering of the engine pretty much. Well, Hazel currently works on Linux, so all of that stuff to do with DirectX 12 DXC and DirectX 12's reflection API, that's all fine. So I guess we wouldn't really see any benefit of it being easier since it's already done. Okay, so materials. So we create materials here. Yeah, that I guess I kind of would like to do. That requires a reflection system, but ultimately we can probably somewhat implement this now. Vulkan material we actually excluded from the project anyway. So that would just probably mean that we just basically get rid of this. And we just make it, I don't know if half of this stuff, it should work actually. I mean, this is going to be a decent amount of work, but it has to be done, probably. Okay, where's Hazel? Hazel. Okay, so, what's this? These are all these get things. So let's just do this, shall we? Because that definitely works, although it does go through descriptor set manager. That's probably okay. And then all of these, right? Like, so what does that do? Yeah, mostly does this stuff. Prepare is a function just in here. Descriptor set manager, I guess we still kind of decided to include. Copy, yeah, okay, sure. I mean, no, we'll have to get rid of this though. All right. included. Might be a recursive include. Material asset. But why would material? Material wouldn't include that though. Unless it was in descriptor set manager. Which does include a whole bunch of stuff. Welcome shader. It's gotta be that. Storage. Very annoying. What? I'll have to maybe trace the includes or something, I don't know. Because it's odd that it's coming up with that. Why does the descriptor set manager include so much stuff? I guess it needs to. I don't think it really needs to include Falcon Shader though. It needs a normal shader there. It does actually need a Vulkan shader, doesn't it? Okay, fine, we won't touch this for now. I'll probably rewrite this anyway, so I'm not too fast. We can just forward declare this, get rid of that. I mean, that's a bit annoying. Or we just get rid of what it does, to be honest, because that's gonna change. Let's just get rid of it. Because I gotta rewrite that class anyway, so I guess there's no point in trying to just make it compile. It doesn't mean this will all return null. Not all of it, but a bunch of it. Oh, what's compiling this? Renderer is compiling Vulkan material. Why? How does renderer suddenly include Vulkan material? Vulkan renderer includes it. And we include Vulkan renderer. Okay, Vulkan render command buffer. Material get shader. I don't think I had these implemented either. They can just be blank. Again with this stuff. This is getting annoying. It's like, how does this actually happen? Like, we've already got a window, right? GLW maximize the window. And then that ends up calling this. That seems reasonable. And then this. So the window here is D150. What's our window here? Yeah, D150, what the heck? It's the same window. I mean, as you would expect. But yet the device manager here is not correct? Like what? Like that doesn't make any sense. What, like what? Yeah, it's D150, A24, E31. Yeah, it's the same window. So why is it not getting the right user pointer? Like, that's a bit weird, isn't it? So 1A23EF, BB0. Just remember BB0. BB0 should be what? Should be our device manager. And we did copy the window into here, right? Whoa, we're creating a new... No, okay, we're creating a new window, yes, but the window... M window is from the device manager. Right. Oh, it resets the user pointer to data. Okay, that's why. That should fix all those errors, I guess. But also this won't work anymore, but that's okay. Potentially. Can't be both anyway. Or we just get it to not reinstall callbacks, but we'll see. Oh, it's full screen. And here we go. Oh, okay. Thumbnail generator's not happy. That's to be expected. Because something's null. Could it like not get that asset? Oh, that's not good. Begin tracking texture state before using the texture, or use keep initial state and initial state members of texture description. Yeah, okay, so this is us not using NVRHI properly, which is fine. Maybe I could just not create the thumbnail generator for now. Because that's not gonna work, obviously. I did not know we did this at this point. Could skip that. Probably gonna happen a few times. Scene renderer in it. That's not gonna work out. What is this code? Weird. Okay, we might wrap it up here. We're pretty, like, decently into runtime here. We've almost finished. We're, like, very close to actually beginning rendering. Obviously, now we have to set up, like, the scene renderer and all of that stuff, which is what's going on here and what isn't working. I don't know, like... At this point, I'm not sure which direction exactly we should go. Like, as in, do we just try and get this rendering UI frames? Like, get it rendering frames, and then we start going back and making the rest of Hazel's renderer work piece by piece or something? Or do we just go through what it's trying to do here and, for example, kind of make it work with, you know, the scene renderer? But then, like, that requires us almost making all this work. Like, I would probably be more inclined to just... Yeah, I probably wouldn't do that. I probably would just disable... Because remember, we wanted to disable viewports anyway, and obviously the scene renderer is for the viewport. So I'd kind of just, like, get rid of these two. And renderer 2D, you know, which gets created probably earlier. And just make it work probably like that. That way we can actually make sure the rest of the application with the life cycle and the actual rendering the swap chain of the application works first before we start going into actual how does Hazel render the scene. So anyway, that's what we'll do next time. So if you go to the schedule on my Twitch page, you'll see when the next stream is, which is in a couple days, but in the morning, different time zone. So yeah, anyone have any questions before I go? Of course, you can get access to Hazel and help support the project by going to patreon.com/thecherno. And a huge thank you to everyone who does help support the project, because that's why we're here. Yeah. Cool. Alright, well, I'm very tired, so I'm gonna get some nice, good sleep. Thank you guys for watching. I'll see you next time. Goodbye.